Hi there, my name's Jackie Decker, and this is the second part of a video series on From Patterns to Algebra, which is based on this resource by Dr. Ruth Beatty and Dr. Cathy Bruce. The introductory video highlighted lessons 1 through 5 and lesson number 9 from this resource. This video, part 2, is going to focus on using lessons 6, 7, 10, and 11 from the resource, and along with some thinking routines to build a deeper understanding of linear relations. We're going to begin with lesson 6, which focuses on comparing different pattern rules for students to build that deeper understanding. And there's going to be a particular focus on helping students understand that the multiplier in a linear pattern is related to the rate of growth of that pattern. So we might do a thinking routine called Which One Doesn't Belong. And in Which One Doesn't Belong, we're actually asking students to think about why each thing doesn't belong with the others. What does that look like? In this case, a teacher and I built 4 different linear growing patterns using color tiles, and we just took a picture of it on 4 desks in the classroom. And we showed that picture to students, and we asked them to give us a good reason why each of those patterns was unique. And by comparing these patterns, it allows us to see what the students remember and understand. It allows us to see the math vocabulary, and then it lets us know where students are so we can continue the learning from where students are at in that understanding. We might also use the thinking routine, the 3 V's, which stands for visualize, verbalize, and verify. What does that look like? Well, we might give them a question. So in this case, we're going to compare 2 written rules for growing patterns. And so in this case, we have the number of tiles is the position number multiplied by 5, add 2. And the sort of reverse pattern, position number multiplied by 2, add 5. And we're going to ask students this question. Do they think the patterns for the 2 rules will be the same or different, and why? And at first, we're going to ask them to just visualize quietly the growth of those 2 patterns. And then we're going to allow them to verbalize and speak to each other and to talk about their thinking. And then we're going to give them some tiles, and we're going to allow them to verify whether those patterns look the same or different and why that might be. Continuing to compare those 2 different patterns, we might ask this question instead. Will one of those patterns grow by more tiles each time? Another question we might ask about the same pattern is which pattern rule will have more tiles at the 10th position? You might use pictures of your own student work to consolidate this learning. And some more student work here. Then we're going to move into lesson 7, where we're going to remove the scaffold of 2 colors. So we don't have a different color now for the constant and for the multiplier. And this is going to increase the cognitive demand of the tasks that we're going to do and help students build a deeper understanding of linear relations. We might show them a pattern like this using 1 color, but we still have a little bit of a scaffold where the tiles have a different orientation. We might do a think, pair, share for students to figure out this pattern rule. And then we'll try another where we've now removed the scaffold of the different orientations of those tiles. And after they've had some practice guessing the pattern rule for some given patterns, we're going to go back to the work that we did in the earlier lessons, but this time students are only going to use 1 color to build each pattern rule, but we're going to ask them to build it at least 2 different ways. And the reason we want them to do this is because we want them to think really deeply about the fact that that multiplier is what's going to tell us there's a constant growth rate in that linear relation. And we want to really push them towards that multiplicative thinking, and letting them see that multiplication in more than one way will help with that. After we have done that, we're going to ask students to think about this functional thinking, this relationship between the position number and the number of tiles and working in both directions. And this is going to help them move from that multiplicative thinking towards functional thinking, which we know is going to benefit them throughout secondary math. For the next task, we might ask students an open problem like this. Given only position 1 with only 1 color, we'll ask students what might the pattern rule be and ask them to think of as many rules as possible that might be true. After they've had some time, some quiet think time and some group think time, we're going to give them more information, and we're going to say, so if we give you position 3 of the pattern, what does the pattern rule have to be? Which of your pattern rules work for this? If none of them did, which pattern rule might work for this? Here are some photos of some student work where students were using color, reintroducing that scaffold of color, or making groups of or small arrays to help them figure out this pattern using the tiles. Other students systematically wrote out many different pattern rules, moving from that concrete to the more algebraic model. And here we see a student clearly connecting the algebra to the visual, and we can use student work like this to help all students make those connections between the different representations of a linear relation. We can then put it back to students. So now that you know what an open problem looks like, can you come up with some pattern rules that have the same number of tiles in position 1, but different numbers of tiles in position 3? So to briefly review lesson 9, this is when we ask students to connect a pattern rule that they've built and ask them to create a graph using those square tiles and eventually transfer that to some grid chart paper. When we do that, we get work that looks like this. So you can see that in wanting to connect those two representations, we've returned to the scaffold of having the two different colors for the constant and the multiplier. We see some students putting that constant at the top of the graph, some at the bottom of the graph. We can talk about what we learned from those different representations. We can help students then create a line graph from their bar graph and use color to connect that to the algebraic representation. And then we're going to move into lesson 10, where we really want to make a really strong connection between the multiplier and the rate of change and the steepness of the graph. And we might ask them a question like this. Here are two pattern rules. Which graph is going to have a steeper trend line? And why do you think that's true? This comparison will have students really debating and thinking more deeply. We're then going to move to lesson 11, where we ask students to think about pattern rules that have different multipliers but the same constant. And we're going to ask them how they think these graphs are going to look. And we might go through the 3 V's, visualize, verbalize, verify. And after going through that, in this case, we might then move to a case where we have the same multiplier but different constants, because we really want students to build a strong connection between the equation and the graph so that they better and more deeply understand the role of the constant and the role of the multiplier.